EMI? RFI? WTF? Hi, and welcome back to Feniex Focus. I'm your host, Katya, product manager here at Feniex Industries. Today, we're going to tackle one of the most annoying, irritating, aggravating, obnoxious, yes, that. It's a phenomenon known to us as EMI, or electromagnetic interference. You guys may know it as RFI, or radio frequency interference. In the emergency warning industry, it can cause a serious problem for first responders during critical radio communication. But what causes EMI, and how do we prevent it? Well, high-level engineers have been battling this problem since the dawn of the semiconductor. Most power-related systems can cause some form of EMI, but the main issue stems from the power regulators found in your electrical products. Power regulators take the input voltage from your source and lower it based on what the electrical device needs. If the voltage exceeds what the device can handle, it will cause permanent damage. In your home, the standard power provided by a US grid is 120 volts AC. Once we started introducing other devices such as TVs and vacuums that required less than 120 volts, power regulators were needed to prevent overvoltage. The same applies to the devices in your 12-volt powered cars. Radios, LCD screens, and LED warning lights require less voltage than what is provided, so a power regulator is needed. Linear and switching regulators are the two main electrical topologies used to control input power to LED modules found in modern-day light bars. Again, the standard power found in a vehicle is 12 volts. Your average 1-watt LED consumes 3 volts. When running 12 volts to a single 3-volt LED, it will cause instant failure due to a power overload. A linear regulator steps in and provides a 9-volt drop, setting a safe output of 3 volts required by the LED. Now, there are a few downsides to this method. First, it requires a very large and bulky metal frame to dispense all that built-up heat. The heat, in turn, significantly lowers the overall life of the LED module. Also, only 20% of the power being consumed is producing light, while the rest is wasted energy. To combat the downsides of a linear regulator, engineers came up with a new way to regulate power, known as the switching regulator, an advanced yet simple circuit in which a switch connected on the power line is turned on and off at a very fast rate by a microprocessor, yielding a simulated voltage drop. How fast? Between 500,000 to 2 million times a second. This method solved many previous problems that linear regulators struggled with. You have virtually no added heat, the life of the product is considerably longer, the size of your metal frame can be ultra small and compact, you're operating close to 95% efficiency with very little wasted energy, and you're also able to run high-powered LEDs that can produce far greater light. Unfortunately, the manufacturing cost of a switching regulator is around $2, which is 10 times the cost of a cheap 20-cent linear regulator. That can add up quickly for a company like Feniex that produces close to 1 million modules a year. The last and biggest downside to the switching regulator is the dreaded EMI. So, how does a switching regulator produce EMI? And how does this affect my devices like my radio? Well, it all has to do with the little switch on the power line. When the switch opens and shuts at lightning speeds, allowing power to pass through, it creates a magnetic ripple effect. That's what we call electromagnetic interference. If your radio is in close proximity to the lighting device using that switching regulator, the antenna will pick up this magnetic field and process it as static noise. That noise will most likely override any communication in your radio, hence the name radio frequency interference. There are actually two types of electromagnetic interference: radiated, which is transmitted directly from the module itself, and conducted, which runs down the input power lines like a virus affecting any product connected on that line. Very scary. Only the very best engineers have been able to develop sophisticated filtering circuits to control this magnetic rippling effect. These circuits work like a drain inside the device, sucking and absorbing just enough energy away to counter the magnetic ripple effect. It took a team of 20 engineers here at Feniex Industries over 3 years and over a cost of $1 million to create our EMI-free switching regulator circuits used in all of our LED products. Fun fact, the first light bar Feniex developed in 2009 produced enough EMI to jam all personal, police, fire, and aviation radio communication within a 2-block radius. Ah, growing pains. The emergency warning industry is just like every other business, and many big decisions are based on cost. While linear regulators are cheap and easy to manufacture, they're hot, bulky, and have a really short lifespan.
What?
Switching regulators are thin and compact, ultra bright, but they cost a lot more to produce. So do your research if you're not buying Feniex, folks. Check if your product is powered by a linear or a switching regulator, and if switching, verify that it doesn't produce EMI, which could jam your radio communications and stop you from saving lives. Thank you for watching this episode of Feniex Focus. Still think linear is the way to go? Weigh in below with any questions or comments. Or got an idea for a show? Let us know. Make sure to subscribe to our channel as well. See you next time.